Thank you. Good afternoon, everyone. As I was introduced, I'm Greg Tinney-Crook, and I'm the Laboratory Director at Aevitas Fertility Clinic in Cape Town. So like many of you here today, there are many couples and individuals out there who have one common goal, and that is a healthy baby. However, it's often unfortunately necessary for many of these people to seek help at fertility clinics. So fertility treatment can be an arduous journey, but hopefully the result will be a little someone who will fill your life with much happiness. Fertility treatment is complex, with many aspects to consider. These include egg collection, the fertilization procedure, and embryo transfer. And identifying the best eggs and sperm and embryo is essential. So under natural circumstances, the body assists in selection. For instance, the cervix blocks dead sperm and allows the foster swimmers to move up the fallopian tube first. Also, the body normally rejects abnormal embryos. However, in infertility, the trained embryologist needs to step in to assist. So let's talk about sperm selection. So firstly, what is sperm quality? So from a reproductive viewpoint, it is the capacity of a single sperm to fertilize an egg, create a developing embryo with the ability to implant and evolve until a live birth, hopefully healthy, is achieved. So why do we find it necessary to look for the best sperm? Well, mainly because fertility treatment is not 100% effective. And regardless of the source of sperm, not every patient succeeds, and several attempts are needed. During the procedures, the embryologist chooses the sperm to use and is participating in the selection of that sperm. Selection of one sperm may result in a good embryo, resulting in a live birth, and selecting another may lead to failure. So for the embryologist selecting those sperm, there's no pressure. Now we'll touch on the various methods for selecting sperm. The most basic selection procedure would be in semen preparation. And this is done, it's a self-selection process, and it's done when we prepare the samples, the semen samples, for artificial insemination, IVF, or Emcee. And it's done normally through a swim-up method or a density gradient, where the swim-up method would be where the sperm will select themselves as being the better ones. So I've just said it, the sperm select themselves on the basis of motility, and this process is independent of the embryologist. Then we can look at morphology. Now, morphology is looking at the shape of the sperm. It is a very subjective assessment. So in other words, the embryologist looking at the sperm makes the decision whether the sperm is normally shaped or not. And it's dependent on the skilled embryologist. So just to go back to some basic science, this is a sperm. At the bottom there, you'll see it's got a head, a midpiece, and a tail. And all of those various parts of the sperm can be assessed and looked at to see if the sperm is normal. So out of the millions of sperm that are in an ejaculated sample, or in a sample that we look at, there are many things that can be wrong with the head, the neck, or the tail of the sperm. And we will grade those sperm to look for the normal sperm on the left-hand side. and those sperm we will then use in fertility treatment. So that is morphology. There are more advanced selection methods that we use in the laboratory for selecting the better sperm. The first one that I'd like to touch on is called Emcee. So just to remind you, an Emcee is an intracytoplasmic sperm injection. In other words, we're taking a single sperm, injecting it into the cytoplasm or the body of the egg. Whereas Emcee is physiological Emcee. That's what it stands for. And it's based on the ability of mature sperm to bind to droplets of hyaluron, which is a naturally occurring acid in the body, on a dish, on a Emcee dish. So this is an example of a Emcee dish. On the bottom left, you can see the actual dish with the little yellow dots, and those are the droplets of dried hyaluron that are then rehydrated. The sperm is added to the dish, and the mature sperm will then stick to that dish and are available for selection by the embryologist. And, it selects for physiologically mature sperm. So this is what a dish would look like under the microscope to the embryologist, where there are many sperm stuck to the dish, and then the embryologist will use the Emcee machine, which is this fancy machine at the bottom here, select an individual sperm into the pipette at the top, and then those individual sperm are injected into the egg. And you've selected a good-looking, a morphologically good-looking sperm that is also physiologically mature. So some research has shown that Emcee is linked to reproductive success with higher pregnancy rates and fewer miscarriages. However, the research was not well controlled, and new publications show that there is not enough evidence to implement the routine use of Emcee. So Emcee will be used in many clinics for only certain patients who request it or need to have that done for them. So it's not routinely done. The next that we will look at is Emcee. And Emcee is a type of Emcee. It's an intracytoplasmic morphologically selected sperm injection. So we're looking very closely at the morphology, and it's a method of unstained, live, high magnification examination. And this was we are able to do this because of the developments in magnification on our Emcee machines that allow us to look very closely at the sperm. And the high magnification allows the embryologist to see very subtle defects in the sperm. So for instance, this is a picture of an Emcee being done, and you will see, if I can get this pointer to work, the sperm has got lots of what we call vacuoles, so we will not use those. Whereas this sperm doesn't have any vacuoles, it's got a nicely shaped head, and we'd possibly use that sperm for the Emcee. So we would reject the sperm that do not look good. And there are some more pictures of different types of problems with the sperm. So some trials have shown that there's an improved implantation rate by using Emcee. However, taking everything into account, there is no support for the wide clinical use of Emcee, but it may be applicable to a subset of patients. So certain patients will benefit from an Emcee, but you'll find that most clinics will not be doing this routinely. Let me talk about DNA fragmentation, and many of you that have been to clinics the men may have been sent for DNA fragmentation tests. And this, strictly speaking, isn't a sperm selection method, but it is information it is a process that gives us information about the man's sample. So DNA integrity is crucial in order to release the paternal genetics properly to the egg, resulting in a healthy child. Broken DNA may not be able to do its job properly. So there are various tests that are done to look at the integrity of the sperm DNA. And there's a lot of information out there which is often very confusing. There are a number of scientific articles and reviews that have conflicting results. So two of the major embryology societies in the world have given out or have put out guidelines relating to DNA fragmentation, and they say that existing data does not support a consistent, strong relationship between abnormal DNA integrity and reproductive outcomes. There is insufficient evidence to recommend the routine use of sperm DNA integrity tests in the evaluation and treatment of the infertile couple. Then we'll talk about testicular sperm, and once again, not strictly speaking a sperm selection method, but it is reported that there's a benefit when using testicular sperm instead of ejaculated sperm in certain cases. And this is done even if a man has got sperm in his ejaculate, we may still go for testicular sperm. So it is useful for patients with very low sperm counts or with men that have got high DNA fragmentation, because it is shown that sperm from the testis can have lower DNA fragmentation. So prospective and randomized trials show benefits, but the quality of the information is not that good, and there is need for more trials on this particular, let's call it a selection method. So those are the major sperm selection methods. There are other selection methods that I'm not going to actually touch on really. Magnetic activated cell sorting, electrophoresis, and birefringence. You don't have to worry too much about those. They're not routinely done in clinics. The top one might be done by some clinics, but is very expensive. So these are not really done, but they are available to be used. So sperm selection is a vital part of the fertility procedure. However, selecting sperm the way we currently do is yielding relatively poor results. Many of the advanced sperm selection methods lack good scientific evidence to support generalized use. And there's no one-fits-all sperm selection method available to significantly improve success rates. Finding good sperm is possible, but finding the best sperm is difficult. So that's the sperm side of things. I will talk briefly about the embryo selection. And here you can see a little dish with embryos that are all wanting to be chosen, and they all think they're the better ones. But it's up to the embryologist and science and the technology that we have to be able to select the best embryos to go back. Right, so for embryo selection, we have non-invasive and invasive methods. The non-invasive being looking at the shape or the morphology of the sperm, of the embryo, and also testing of the media that the embryos are growing in. And then the more invasive method would be pre-implantation genetic testing. So embryo selection based on morphology alone has not resulted in high success. This has resulted in a strong drive for finding alternative selection methods. So we'll briefly touch on the non-invasive selection methods. And we'll look at firstly the timing of division of the embryo and also the quality of the embryo, or looking at the fragmentation. So here we can see a little table of embryos at different stages, different days, from day 1 through to day 5 or 6. And on each day, the embryo should be at a certain stage. End of day 1, the embryo should have divided to a 2-cell. Day 2, it should be at a 4-cell. Day 3, an 8-cell. then it should become what's called a compacted embryo, and then on day 5, hopefully we are at the blastocyst stage. And if the embryo is at that stage, by that day, it is deemed to be a better quality embryo than one that has not reached that stage. Then we can also have a look at the quality of that embryo on that day. And this is what we call looking at the fragmentation. So when these individual cells divide from, for instance, a 1 cell to a 2 cell, they should divide cleanly and evenly, and there should be no bits and pieces that are left out of each cell. But sometimes the embryo will be a little bit genetically abnormal, and they actually can rectify that genetic problem by rejecting some of the DNA. And that shows itself in these bits and pieces that are ejected from the embryo, otherwise known as fragmentation. And the more fragmentation you have, the poorer the quality of the embryo. So we would love to have an embryo that looks something like this with 0 fragmentation, and we would reject these ones that have just fragmented, that have got huge amounts of fragmentation, because they are probably genetically abnormal. I seem to be stuck. All right, then we can have a look at blastocyst grading, and many of you that have had treatment will know about this. Going back to a little bit of basic science, or looking at what a blastocyst looks like. So this is a day 5 embryo, and you will have this big cavity called the blastocele. You have this blob of cells called the inner cell mass, and the trophectoderm, which is the lining of the blastocyst. This blob of cells, the inner cell mass, becomes the actual fetus itself. The trophectoderm becomes the placenta, and yeah, obviously the blastocele cavity is formed by the secretion of fluid by the embryo, and it gets bigger and bigger and bigger over time. So these blastocysts can be graded, and what we will look at are 3 things: expansion, inner cell mass, and trophectoderm. And you will grade the size of the blastocyst from 1, 2, and 3, 3 being the biggest. The inner cell mass, if the cells are very nice and tight, if they're loose, or if they're absent. And then the trophectoderm, nice, small, scalloped cells, looser cells, or absent. And you will grade that embryo then, for instance, as the top quality would be a 3AA. And this slide is just some examples of embryos that we've graded. And this one would be a very nice 3AA, tight inner cell mass, trophectoderm. This one has got a poor inner cell mass and no trophectoderm, and is a little smaller. So that's grading of blastocysts, and this is one of the selection methods that we use to get the best embryo. And it is thought that something that looks like a 3AA would be a genetically good quality embryo that we then want to transfer. But we have found that those embryos, even if they get to that stage, can be genetically abnormal. But based on morphology alone, basically based by looking at the embryo, we would have to go for the better looking embryo. Then we can have a look at time lapse, or otherwise a fancy name was morphokinetics. And many of you that are at clinics will know about time lapse. And so basically normally in most labs, embryos are taken out of the embryo incubator and assessed once a day. And this gives a very static picture of the developing embryo. Time lapse uses an incubator with a built-in camera for automated imaging of the embryos in a closed incubated environment from fertilization to embryo transfer. And this little machine at the bottom is what many of the clinics will have. It's the more popular of the time lapses. This is an embryoscope, where the embryos are put in and they're left for 5 days, but they are recorded for those 5 days. And the embryologist will then look at various things to assess if those embryos are better, if one embryo is better than another. So as I say, the system allows the embryologist to distinguish and choose between normally developing embryos with good quality potential and poorer quality embryos. There are other non-invasive methods that I'm not going to talk about, mainly because they're not used in the labs routinely, but we can have a look at oxygen consumption of a specific embryo. We can measure how much oxygen that embryo is using. And also we can look at biochemical markers measured in the droplets of the media that those individual embryos are cultured in. Sort of very scientific, and not routinely used in labs, not routinely available. And then lastly, I'm going to talk about the invasive method of pre-implantation genetic testing, which many of you will know about. So PGT allows the embryologist to distinguish between chromosomally normal and abnormal embryos, otherwise known as euploid or aneuploid. Two fancy names for normal and abnormal. So you will get the euploid embryo or an aneuploid embryo, and you would you would choose the euploid embryo. You can ignore the middle one, it's mosaic. It's more complicated, so we're not going to touch on that now. So PGT is an invasive method whereby cells are removed from the embryo and they're not tested. So here you can see an embryo being held by a biopsy pipette, by a holding pipette. And this is a biopsy pipette that then sucks out those cells, some of the cells from the embryo. It doesn't damage the embryo or doesn't genetically damage the embryo by taking those cells. And then those few cells in that pipette are then sent away for genetic testing, and they come back and they tell us, is this embryo normal or not, and can we transfer it? So it is invasive in that you're grabbing those cells and you're yanking that embryo around, but it does have the advantage of giving us the knowledge that a chromosomally normal embryo is being transferred. And genetic testing is not for all patients, it's not necessary for all patients, but it can be done to give us that information. So basically, by selecting your best sperm, having your good quality egg, and getting your best quality embryo, we hope that you can have your best quality little baby. Thank you.